Good day, ma'am. Myself, Kottapalli Blessy Sterlin. My roll number is 234G1A0424 and my branch is Electronic and Communication Engineering. Today, I'm going to discuss about diffusion currents of subject Engineering Physics. Subject code is 23FPHY01 and I'm the student of first BTech first semester. This is my CIA2 assignment PowerPoint presentation. Today I would like to discuss about diffusion currents. These are the following topics I would like to discuss in diffusion current: semiconductor, current flow in semiconductor, types of current flow, diffusion current. These are the 5 main topics I would like to discuss in diffusion current. Firstly, I would like to tell about semiconductors. Semiconductor. Semiconductors are materials which have a conductivity between conductors, generally metals, and non-conductors or insulators such as most ceramics. Semiconductor can be pure elements such as silicon or germanium or compounds such as gallium arsenide or cadmium selenide. A semiconductor is a substance that has specific electrical properties that enables it to serve as foundation for computers and other electronic devices. It is typically a solid chemical element or compound conduct electricity under certain conditions. And now I would like to tell about another topic, that is current flow in semiconductors. Current flow in semiconductors arises from the motion of charge carriers in both the conduction bands and valence bands. As explained, the mobile charges in the conduction band are electrons and those in the valence band are holes. The current is in general made up of two components, drift current and diffusion current. Although in certain instances one or other of these components, drift current, occurs in the presence of any electrical field, which as a result of the force it causes to act on each charge carrier produces a net motion of positively charged carriers in same and negatively in opposite sense. And this is about the current flow in semiconductors. Now I would like to tell about how many types of current flows. There are two types of current flows, that is drift current and diffusion current. Today I'm not going to discuss about drift current, but I'm going to explain briefly about the diffusion current. So let's see what exactly means a diffusion current. So let's see. Diffusion. Diffusion is a kinetic process that leads to the homogenization or uniform mixing of the chemical components in a phase. So actually I would like to explain what is meant by diffusion first, and then I'm going to be in a diffusion current. Although mixing in a fluid may occur many length scales as induced by macroscopic flow, diffusive mixing in solids by contrast occurs only the atomic or molecular level. Diffusion theory provides a way of transitioning from the equation, which provides the solution to the equation of transfer for the cases of homogeneous optically thick. This is about diffusion. Now I would like to tell what exactly means a diffusion current. Diffusion current is a current in a semiconductor caused by the diffusion of charges carriers, example electrons or electron holes. This is the current which is due to transport of charges occurring because of non-uniform concentration of charged particles in a semiconductor. Diffusion current is due to concentration gradient of charge carriers across the junction, and it is due to majority charge carriers. This is about the diffusion current. Now I'm going to show what is the equation. Moving of charges from high concentration to low concentration. Let delta N be carriers, concentration of electrons, and delta P be carriers, concentration of holes. From Fick's law, rate of carrier diffusion is proportional to negative density gradient. Rate of diffusion alpha minus dou into delta N divided by dou X. That is equals to minus dN dou of delta N divided by dou X. And now Jn diffusion is equals to minus E of rate of diffusion. That is equals to E dN dou into delta N divided by dou X. Diffusion I, density due to holes. Jp is equals to minus E dP dou into delta P divided by dou X. Total current density is equals to holes. Jp is equals to Jp into drift plus Jp into diffusion. Jp is equals to Pe mu Pe plus minus E into dP dou into delta divided by dou X. Total current density due to electrons is Jn is equals to Ne mu Ne plus E dN dou into delta N divided by dou X. This is the final equation for diffusion current, and this is all about my topic. Now, thank you ma'am for giving this opportunity to express my PPT, and thank you for giving this golden opportunity. Thank you ma'am.